All right, you guys, we're going to work the second half of the review. We are on number 13. A sphere has a radius of 6 centimeters. So we have a sphere, that's the 3D, and a radius equals 6. What is the area and volume of the sphere? All right, well, area they're talking about is surface area. Surface area formula is 4 pi r squared. So if I plug in my radius of 6, I would want to calculate 6 squared times 4, which comes out to 144 pi. So my answer would be 144 pi centimeters squared. For volume, the volume formula is 4/3 pi r cubed. Since our radius is still 6, we want to calculate 6 to the 3rd power, which remember on your calculator you would type in as 6 caret under the clear sign right here, 3 times 4 divided by 3, and that comes out to 288 pi. And centimeters cubed for our units. All right, number 5, we have a volleyball that has a radius of approximately 3.9 inches. It is covered in leather, and the casing is attached with an adhesive, so no material is needed at the seams. How much leather is needed to cover the volleyball? Essentially, if we're talking about covering a volleyball, you're talking about a sphere that has a radius of 3.9 inches. And then if we're covering it, that's describing the surface area of that sphere, which again, that formula is 4 pi r squared. So I'm going to take 4, multiply by pi, and times 3.9 squared. Since it says round to the nearest tenth of an inch, I'm going to type in 3.9 squared times 4 times the pi button, which comes out to 191. And nearest tenth would be 191.1. This would be inches squared for area. Number 17, you are making a copper flower box in the shape of a prism, a rectangular prism, and it has an open top. So we're not overlapping any material, we're just literally putting the sheet of copper around the box. If you're forming a box or talking about wrapping a box and not filling, filling describes volume, but we're wrapping or like forming this box, so that describes the surface area of a prism, which that formula is perimeter times the height plus 2 area of the base. And the fact that they've told us it's an open top means there's nothing on top of this shape. So that means my surface area normally includes the edges around, or the faces around, and top and bottom, but I really only want to include one of my bases. So I could either scratch out this 2 and only have one base, or I can subtract the area of the base from the top out of that total surface area. So now I need to find my pieces. The height of my prism is 4. I need to calculate perimeter and B. My base shape here, we could just use the bottom since it's a rectangular prism. So perimeter of the bottom would be 12 plus 5 plus 12 plus 5, which comes out to 34. And the area of the base is a rectangle, so that tells me length times width would be 12 times 5, which comes out to 60. And now I can plug into my formula. P is 34, so I want 34 times the height of 4, plus 2 times the area of the base, minus an area of the base. So 34 times 4 is 136, plus 120, minus 60. That comes out to 196, and our units would be inches squared since we have a surface area on here. Number 19. Number 19 gives us this shape, and we have a refrigerator with the dimensions shown. A refrigerator is a prism, So we want to use our PRISM formula, and find the approximate volume. Well, first we need to identify our base. Base shape here is a rectangle. And the volume formula of a rectangular prism is area of the base times the height. So to calculate the area of this rectangular base, that would be 2.5 times 1.7, which comes out to 4.25 for capital B. The height is the distance between my bases, which would be 5.25. So I'm going to multiply those two numbers together to get my total volume. That comes out to 22, for rounded to the nearest tenth would be 22.3 feet cubed. All right, on to the next page, number 21. 21 wants us to measure this cube to the nearest eighth of an inch. So we're just measuring on the inch side. Since this is a cube, every little piece is all going to be the same size. So I just need to pick one and measure that. So I'm going to line it up at 0. This comes to about So from 0 to 1 comes about to 1.12345 1.6. That's inches. And since this is a cube and I want to find the volume, hello, question that's at the bottom. I want to find the volume to the nearest cube inch. Okay, so I'm going to take volume as area of the base times the height. Well, if all of these are 1.6, that means my area of the base is 1.6 squared. So 1.6 times 1.6 times the height, which is 1.6. So 1.6 times itself 3 times comes out to about 4.096, which is 4 inches squared. The number closest to that would be A for 3 inches squared. Cube, sorry. All right, number 23. Melissa bought party hats for her birthday party. She wants to use them as favors and fill them with jelly beans. So she's got hats that are 8 inches high, which is labeled, and 7 inches is the diameter at the base. Again, we don't care about diameter of circles for these volume and surface area formulas because they all require a radius. So I'm going to go ahead and say, okay, well, if the diameter is 7, then half of that would make the radius equal to 3.5, so I don't accidentally use 7 as my formulas. It says if 8 jelly beans can fit into 1 cubic inch, how many jelly beans can fit into the hat? Well, we have to figure out, first of all, if we're filling this hat, and we want to find the volume of that hat. And volume for this particular shape has a circular base meets at a point. That means it's a cone. So volume of a cone is pi r squared h divided by 3. My radius is 3.5. My height is 8. So I really want to calculate what is this value. Since we're estimating how many jelly beans, we're going to go ahead and type pi in the calculator. So this number, the volume, is going to be 102.625-ish. It keeps going, but we'll stop there. So that's the total volume of the cone. If I can fit, that's inches cubed, if I can fit 8 beans, 8 jelly beans, and one of those, I need to take the 102 and multiply by 8 to figure out how many total jelly beans there would be, which comes out to 821. Says about how many jelly beans. We're rounding to the nearest whole number here because you don't have a half a jelly bean that we're using. So we're just going to have 821 jelly beans. All right, 25. We have dimensions of any solid are tripled. What is the volume? How is the volume always changed? So it doesn't matter what we're starting with. Anytime we're changing dimensions or comparing volumes, etc., you need to use your SPAV chart. If my dimensions are tripled, that means that my side or scale factor ratio is 1/3 or 3:1. You can do it either way. Perimeter is going to be the same ratio. Go ahead and finish filling it out. Take the side ratio and square it to get area, which would be 1/9. Take the side ratio and cube it to get volume, which would be 1/27. So they're asking me, hey, how has volume changed? Well, it's 27 times the amount of the original, so I would choose A. That is a direct SPAV chart question. Number 27. 27 is the dimension of any solids are halved. How has the volume always changed? So again, we have dimensions changing, so that's going to be a SPAV chart question. The dimensions, aka the side ratio, is halved, so that's 1/2. Perimeter is going to be the same. Area is going to be the side ratio squared, which would be 1/4. Volume would be the side ratio cubed, which would be 1/8. They're asking how is the volume changing? Well, it is 1/8 of the size. It's getting 1/8 smaller, so that would be D. Number 29, the dimension of a rectangular prism are doubled. That means times 2. If the original volume was 12, what is the volume of the new prism? Well, here's my original prism. We don't care what it looks like. The second one is doubled, so that means my prism is getting twice as big. Okay, the original volume is 12, and I want to find what is the volume of the new one. So we need to do a SPAV chart because we can't directly relate meters cubed to meters. Okay, if the dimensions are doubled, that means we're taking it and multiplying by 2 on the side ratio. My perimeter ratio would be the same. Area is going to be that side ratio squared, which would be 4/1. Volume would be that side ratio cubed, which would be 8/1. Since we're given volumes, we need to use the volume part of the SPAV chart, which would be 8/1, equals, this is a big number over a little number. Okay, so we need to do big over little, which would be x/12, and cross multiply. So x is going to be equal to 8 times 12, which comes out to 96. Since that's a volume, we're going to have meters cubed. All right, you guys, that is the end of our review. If you have any questions, come into tutoring.